Right. Hi, everybody. Let's do a quick intros. I'm John Fancy. I work on the Logic Apps team as a program manager. This is Dan Rosanova. Do you want to check your mic works?
I think it does, because it heard me laughing.
And Vlad, who works on the API management team.
Hello, everyone.
All right. So what we're going to talk about today is integration. So one of the things that lots of customers have told us, I'm sure you guys have experienced this as well, is like, how do I use Azure services better together to create my integration solutions? And there are really kind of three core areas which we're going to cover today. We're going to cover messaging and eventing. We're going to cover the value and the power of APIs, and we're going to cover orchestration in Logic Apps. And the way this kind of looks is like the canonical problem is like I've got a bunch of customers, I've got a bunch of users, I've got a bunch of partners, employees, and then I have all this stuff underneath this. I have things on premises, I have SaaS applications, I have packaged applications, I have custom applications and data. So how do I connect all of this stuff together in an easy and manageable way without kind of still leaving the office before it's like the next day? And this is where Azure really comes in. We've had a lot of investment over the last few years around building out our integration story in Azure. First with messaging with Service Bus, now with Event Grid, recently launched GA'd. And then we have API management, which came along a few years ago, and then Logic Apps, which GA'd 2 years ago. And all of these things together allow you to build rich, robust integration solutions to connect everything together, to connect your customers, partners, multi-channel websites, mobile apps, whatever it is, to your back-end systems and data. Alongside all of these, we have other capabilities as well, aimed at various different audiences in your organization. So we have Power BI for being able to visualize data. We have Power Apps for building front-end mobile and Windows-based app experiences that integrate deeply into these Azure services. So you can write a Power App that calls down to Logic Apps or consumes APIs that can do interesting things against your data. And then we have Microsoft Flow, which is our citizen integrator product. So all of these Azure tools are really aimed at you guys. This is why we're here at Build, to talk to pro developers. And Microsoft Flow is aimed at sort of citizen integrators and developers, people who are kind of going kind of application first, whether it's from Dynamics or Office 365 out. Here we're talking about kind of going from Azure to connect to other Azure services and other data sources wherever they reside. And then finally, of course, we have Visual Studio as our pro tier IDE capability of authoring a lot of this stuff. Okay, so this is called Azure Integration Services. It's on our booth in the expo floor as well. So we're really bringing these services together and messaging them more strongly together, because we're doing in-product features, and we've been doing this for a while to just make them work great together. We have full Service Bus API support in Logic Apps today. We have integration between Logic Apps and API management, and you're going to see a lot of this in the demos shortly. But we kind of span these two worlds. On the left-hand side, we have iPaaS. So Logic Apps is our integration platform as a service. Again, it supports multiple personas. It supports Microsoft Flow, which runs on top of Logic Apps for those citizen integrators. It supports professional integrators for those of you who do integration all day long. They're intimately familiar with XML and data representation formats like EDI and B2B. And then we have this sort of pro developer that we also address with our offering to allow you, if your job is to write code, to easily be able to integrate that code and integrate integration into your solutions, whether you're using Azure Functions or some other mechanism like web APIs to actually implement the solution itself. And it's very approachable when you look at it as an integration platform as a service, because you have a low, no-code, highly productive environment with a graphical designer to kind of create these things. It's template-driven, so you don't have to start from scratch every time. You can choose the best template to get you started, whether that's working with Service Bus to kind of receive and send messages, or whether it's working with EDI, or whether it's working with XML documents. We have a whole bunch of templates in the gallery. And it's API-centric. Everything in Logic Apps is driven from APIs. So all of the connectors that we have I've all described in APIs using OpenAPI specification. So you get a uniform interface and a one way of being able to connect to anything. And then over on the right-hand side, we have serverless. And Service Bus and Logic Apps are serverless technologies, allowing you to move away from having to stand up all that infrastructure before you get anything done. So very quick time to market because you can go straight in and start creating these artifacts, these resources, and get up and running very quickly. It's consumption-based so that you only pay for what you use. And all of this translates into higher productivity, reduced DevOps because you're not having to patch and manage servers all the time. So in the middle of this is this kind of intersection of these two worlds, and this is what we're calling Azure Integration Services. Excuse me. The intersection of Service Bus, API management, Event Grid, and Logic Apps. Dan, take it away.
All right, thank you. Hello. Who in here has heard of Service Bus before? Or used it? Oh, hey, yay! Yeah, we were the hipsters of serverless. Certainly doing it before it was cool, I guess. And who's heard of Event Grid? Less people. Oh, man, that's amazing. I love you. When we look at what we're doing inside messaging and how this really fits into our integration story in the cloud, there have been some funny questions since we launched Grid this year about, well, should I use Grid now because it's out and it's new and new things are fun and shiny and stuff instead of Service Bus. But both of these things are meant for different approaches, and they both support a good integration story in the cloud. And really, the reason we have two of these is, well, they have some similarities in the fact that they're both pub/sub type technologies. They're really designed for different things. Service Bus is really an enterprise messaging platform. If you're thinking about like IBM MQ or Tibco EMS or something like that, that's the place that Service Bus is aimed at. And we're trying to give you those sorts of features. So it's queue semantics. You know, things are in a queue. The queue is a competing consumer. You're polling on a queue, things like that. You get rich filters for topics and subscriptions, instantaneous consistency, strict ordering, all these things that you kind of want in sort of enterprise messaging scenarios. And they come at a cost, both financial cost and a performance cost, but they're super, super powerful. And then you get something like Grid, and Grid's a different type of service. For everyone who's used Grid, do you think it's easy to use? Show of hands, anyone? Yeah, so Grid is so easy to use. It's HTTP post, and you can do it with curl, like from the command line and send messages. But it's designed for something different. And that is really that all of those messages are independent. All of those notifications is what they really are, completely independent. They're actually raised usually by other services. So usually you're not sending them yourself. And it's all push semantics. When I say the messages are independent, it means they can be routed between different infrastructure completely. So there's no order. You do get some filtering and routing, but it's really designed more for notification rather than transition of state. So the way I like to kind of think about it is that Service Bus is me telling you something, and Event Grid is you just telling me that you're interested in something. Like it is putting the story on you as the subscriber rather than me on the publisher. So they really are different. Don't confuse the two. They're meant to do different things. Look at what you're trying to accomplish. In my mind, I see it as if you're trying to move money or material, I usually look at something like Service Bus, where you want these enterprise messaging features that I'm going to talk about a little bit more. I think John is going to talk a little bit more about Grid in his section, so I'm not going to talk too much about it, except to say that this. Grid is really about tying together all of the services in Azure for you so that you can get notifications. You don't have to do polling. Polling gets pretty expensive to do. It gets heavy. I like to do this in talks sometimes. I won't do it today. I pick someone in the audience and ask them to, in their mind, think of like the 7th Fibonacci number. And then I just yell at them, are you done yet? Are you done yet? Are you done yet? Because it's a good example of what polling is doing for you. And so today in Grid, we have all of these publishers and consumers wired up you can use, and John will show you. But again, the idea is that this is really messaging that's meant to be invisible. So it's just meant to be there as supporting you behind the scenes, whereas Service Bus is pretty visible, and we'll talk about that right now. So where does Service Bus fit in? I guess I don't have to tell this group. I didn't realize quite so many people would be using it. I'm very happy, or know about it. I'm very happy about that. It's really about providing durability and decoupling. So traditionally, when you look at an application, you're going to have some sort of front end or UX, some sort of like web front end or something. You're going to have back end that's doing something, like think about like a 3-tier architecture application or something. And to communicate between those components, you want something that's going to be able to be durable and reliable and give you control of how that message flow works. So things like TTL and stuff like that. This is exactly where Service Bus fits in, is to sit in this reliability buffer in the middle. And it's very powerful because, as I mentioned, that Grid is very lightweight and it doesn't get in your way or anything. Service Bus can give you a lot of features in the middleware itself, so in the messaging layer itself. Things like scheduled delivery. Like I have a message and I want to send it. I no longer want to be responsible for this message and I want to send it, but I don't want anyone to read it until sometime in the future. So you can schedule messages to appear in the queue in the future. Even though you've already sent them, they're replicated in Azure, they're safe, and you're no longer responsible, but they're there. And the inverse of that, meaning a time to live. So you can say, I want someone to read this message and do something within 5 minutes, or it's not valid. So that's actually a super useful option to be able to say, okay, if you can't fill this order in 10 minutes, throw it away. That is a super useful feature of something like Service Bus that you're not going to get from other messaging brokers. Other features on here that are pretty interesting. If you're not too familiar with them, the ones I'd look at that are impressive are things like sessions. When you have a queue, there's really no ordering in any queuing system unless you only have one sender and one receiver, right? Because the sender is sending and stuff's going to be in the order they sent it. And if there's only one, you'll have order. And if there's only one reader, you'll have order. So getting order and parallelism in a queue is very hard, but Service Bus does that by giving you something called sessions. Definitely worth looking at. Real quick, I'm going to show you a couple of things about Service Bus just to see what the code experience is like. So this is the Azure portal. I have a Service Bus namespace here already. You can see that there's some queues in it. I've sent some messages, whatever. I don't really need to look at the portal too much. But we do have a good experience for it. You've got your grid integration. You can scale from here, and you can do things like geo-disaster recovery. That's a cool feature that we have for this. From a code experience, Service Bus really couldn't be that much simpler. So this is the code. I guess I will just show this part to actually send to Service Bus. You can see that I'm creating this thing called a queue client. I'm instantiating a new message and passing in a string, and then I'm calling send async on it. So that's pretty easy. Like this works. I can actually run this. It'll work right now. And what's cool about this is that I mentioned all those features. How you interact with those features are through the message itself. So things like this. This is how you schedule a message to show up in 1 hour. So this message will be in Service Bus in Azure, but it won't be visible for anyone for 1 hour. And that's a cool way to do that. I can actually put a time span for TTL on that message easily by using something like this. And then other neat features of this are things that I can do things like add user properties to this. So this is a good example of a very useful user property. It would be to have one that's called message type, and then you can put the type of message that's in here, and maybe the URL to your schema for that type of message. So these headers can be used for routing. They can be used as hints to let you know what to do with that message without having to decode that message or know the format ahead of time. So this is kind of some of the power of what people do with Service Bus that makes it so useful. Receiving is pretty easy too. You can see I actually have code here for a receiver. This is our .NET standard client, so it's a very lightweight client. We have the same thing for Java as well and a few other languages. And receiving is pretty easy too. You literally, in this case, we've made it kind of so you fall into the pit of success. You don't even call receive. You register a callback function with the client, and then it will push messages to you. Interesting piece of that is this message handler options. This is letting you control how many concurrent messages do you want pushed to you from the client, and do you want them to be completed automatically for you when they're done, so you don't have to do any of that yourself. The cool thing with this is you can do almost anything with Service Bus. The kind of question is, should you? And there are often times when you shouldn't, so be careful with that. But there's a lot of power in this and a lot of expressiveness that's interesting, but you don't always need some of that. And so again, when we look at what are these tools here for and what are they doing, some of them are impressive because they're simple. And Grid is one of the simplest things that I've ever been involved with in my career. I'm very, very happy with that. And some things are impressive because of their complexity, and because they can do complex things. So when you're trying to do simple push routing type scenarios or notifications, think about Grid. And when you're trying to do rich, controlled enterprise messaging things, be sure to think about something like Service Bus. And while you're thinking about that, this is kind of the place where I want to leave this so that it ties back into what we're here to talk about today in integration, is that while Service Bus is really powerful and expressive and gives you all these features, you don't necessarily want, especially if they're not people in your organization having access to all those features, you don't necessarily want someone putting messages that you didn't create yourself or approve of in your queues and getting into your middleware. So you might not want to expose all of those TTL features and things to your customers, and you might not want them to know even where you're running this or how you're scheduling stuff. So a good way to get around that is actually to put an API in front of your messaging piece, especially if it's a public-facing service or a service that's crossing teams or organizations that can expose just the subsets of features that you want. And so this is a pretty popular thing to do. I know a few people I know in the room have already done this, where you can have something like API management stand in front of Service Bus and just expose the features that you're interested in. And with that, I will turn this over to Vlad to talk about APIs.
Thanks, Dan. So can you guys tell me how many of you actually use API management? Fair number. How many of you heard about API management? A bit more. Thank you. So how many of you think that APIs are valuable? Almost everybody, right? So I don't have to work really hard to convince you. That's not the slide I want to start with. So don't worry about the somewhat menacing title. APIs are quite harmless. So those of you who have been in the industry for, the last decade, let's say, you'll probably witness the fact that technology landscape is getting ever more distributed. 10 years ago, there was no cloud. There were very few SaaS providers. Devices were dumb, and connected cars were stuff of science fiction, right? So 10 years later, all of these things are growing tremendously, right? As that technology landscape was changing and becoming more distributed, APIs essentially become the default standard of exchanging and connecting things, right? And they started there on the periphery, outside of the firewalls of corporations. And then, as people accumulated expertise in building APIs and technologies mature, those APIs basically trickled in, right, to the core of the enterprise IT. And today, essentially, we are at a point where if you want to expose a piece of functionality, if you want to expose or enable some data exchange, APIs is the default choice. It's not even a discussion, right? Technically, they're very simple, right? There's a few things involved: HTTP, JSON, auth for security, OpenAPI, or also known as Swagger for describing APIs. So it's a very limited technology stack. And anybody can really build an API today. Every language essentially under the sun have at least a handful of frameworks allowing you to build APIs and consume APIs. So the technical challenge is somewhat trivial. Yes, there are finer points. There's a distinction between great APIs and just good APIs and not so good APIs. But in general, if you want to do fulfill some sort of requirement or get something done, getting an API out is not something that is difficult. Now, today, essentially, APIs are mundane. What's interesting about APIs is, and this is what sort of Gartner is talking about, and if you sort of search for value of APIs, you'll see a lot of that. There's even a term for that, API economy. APIs became transformational, right, for many corporations. There's many different examples where organizations derive tremendous value, top-line revenue, and efficiencies from APIs. They use them for mobile apps and connected devices to ensure customer loyalty and satisfaction. They're used to develop ecosystems and get to new customers through partners and affiliate networks. And they're used internally in the enterprise to achieve agility and empower employees to build solutions faster and react to market forces faster. So the other interesting aspect of APIs is that they use a certain set of standards, and they're really easy to consume. So they're actually very well suited for ad hoc integration. Anybody can write a piece of code that calls one API and then calls another API and does something with the data. So that's all great. And but here's where it gets really interesting, right? Where APIs, platforms like Logic Apps, for example, platforms that are API-centric and know how to connect to APIs and orchestrate those APIs and sort of glue them together, doing any necessary transformation logic in between. Those platforms are actually very complementary to APIs because they actually enable you to get the value of the investment you put in building APIs much faster and much easier, right? So it's an enormous sort of force multiplier for APIs. And the other interesting observation about APIs is that they actually are subject to network effects, right, like social networks. Every new API that you expose adds value to all the other APIs because it enables you to connect things in a different way, right? And those kind of things, simplicity, and these network effects, essentially responsible for the quite amazing and exponential growth of APIs. Now, in any API value chain, you have multiple players. Two important ones are people who actually build APIs and people who consume APIs, build apps that consume APIs. So APIs developers and people, managers, we call them, they manage API. We call them sort of publishers. So on the publishing side, you expose these APIs using either cloud technologies or your on-prem stack. And then app developers, they essentially go and build apps that consume that. It's simple, and it's been done, right? But there are certain things that needs to be addressed here. On the publishing side, there's a bunch of concerns that you immediately have as soon as you start publishing APIs for other people to consume. Abstraction, right? I mean, you don't want to, get your API consumers binding to your naked API, so to speak, right? Because then you have very limited options in terms of evolving that API, moving it around, re-implementing this API using different technologies, et cetera, right? The other things that you need to worry about, obviously, is security and protection from overuse, let's say, or misuse. Managing lifecycle. How do you make safe changes and roll these changes out in such a way that you don't impact your consumers? How do you understand who is using APIs? What is used most, et cetera? How you get interesting insight into your APIs and make them better? And then, of course, value of APIs is realized when they are used, so you need to somehow attract and onboard developers on the platform. And of course, monetize the APIs as well in some way. Of course, on the other side, when I'm trying to consume an API, I have my own concerns, right? It's how do I find the APIs? How do I learn what they are? How do I interact with them? How do I self-service on board to use them? And how do I report any problems and get any sort of assistance in coding assets? And this is where API management comes in, right? It connects those two sides, right, and creates this virtuous cycle and really simplifies the concerns and addresses the concerns that both sides have. Essentially, we provide out of the box admin experience, both interactive and programmatic, for you to manage your APIs. On the app developer side, we have a developer portal, which developers use to discover APIs and learn how to use them and onboard and report any issues with them. And then the heart of the product is this gateway that creates the abstraction layer between apps and API implementations and performs all the functions that we discussed in terms of security and protecting, managing lifecycle, monitoring, monetization, and things like that, right? So that product is available in Azure. It's a cloud-only product at the moment. And it can work with APIs deployed on Azure and off Azure. Any API, essentially, that is HTTP-based, and we can connect to, line of sight, basically, we can resolve and connect to, we can work with, regardless of where it's located. We work with APIs located on-prem or privately in Azure using virtual networking technologies, and we have quite sophisticated means of configuring various topologies that are secure and enable API management to be used both by internal and external customers. One of the interesting aspects and the critical piece of API management that I'm going to actually show, so I thought it's appropriate to talk about it, is this concept of policies. Policies essentially are a little encapsulation of common things that you want to sort of management functionality for APIs. Think of it as caching, throttling, transformation, access control, things like that. We have about 40 policies and counting. You can see them sort of on the scroll. They're scrolling over there. You can configure them in the direction from the client to the backend and from backend to the client, sort of as you want to achieve certain things. We have concept of scopes where, you can apply policies and affect a single operation of an API, a group of APIs, or all APIs, right? So you can start thinking about, the power of that sort of abstraction. And the policy is basically composed, right? So if you define something at the global scope, which affects all the APIs, and something that affects only a single API, at runtime we sort of do composition and execute all the policies that are affecting specific requests. So with that, I'm going to show you, this basically slide demonstrates how it works. Essentially, here you can see, I'm showing inbound direction. You've got global product API and operation scope. Product essentially is a set of APIs. And here you can see that some of the policies dealing with cross-domain access and logging are defined at the global scope. At the product scope, you can probably define something like rate limits and quotas to control how much your API can be used by each individual consumer. And then for API, you can set certain authentication rules. In this case, you can validate JWT token, auth token, essentially. And then at the operational level, you can do some transformations and other things like caching. So when a request comes in, we essentially take a look at this request, and based on the information within the request, we map the request to the scopes, right, that policies are defined in, and then we create a composite policy and run it. And that's the same way it works, obviously, on the way from the backend to the client. So now I'm going to show you API management in action. Let me just switch here. All right. So I have an API management service here. Let me go in. So you immediately can see some of the stats about your service capacity, meaning how much of the capacity available to you, and if it's time to scale or scale up and down. Request levels, some latencies. Going further down, you can see that you can manage APIs. You can manage products, which are essentially bundles of APIs that you can target at specific developer groups on all front of the same key and throttling parameters. We have the ability to tag various entities in the system so that you can group and search and filter on those. We've got named values, which I'm going to mention later. That allow you to define sort of your secrets and your magical strings in one place and then reuse them from many policies. And those are sort of securely stored and applied just in time. Manage your users, groups, et cetera. We've got lots of security capabilities there for certificate authentication, auth, OpenID Connect, et cetera. You've got ability to monitor and analyze the traffic using standard Azure tools like Application Insights and Azure Monitor. But the first thing people do when they come into API management is probably define an API, and I'm going to show you how easy it is to do that. So we have a bunch of ways to define an API. You can define an API from a clean slate manually, or you can import it from a number of specification formats. And one of them is OpenAPI, formerly known as Swagger. But also Waddle and WSDL. We support both SOAP and SOAP to REST, and we automatically will convert SOAP endpoint to REST if you like. We've got ability to map or import APIs from logic apps and functions and API apps, and we're going to be adding more of these little tiles here as time goes on. So I'm going to start with importing from an OpenAPI specification. I have an API here running on as a web app. And it has this OpenAPI specification, Swagger description. You can see that it's located, this is the URL for it, and it runs on Azure websites. So I'm going to go and plug it in here. So all I need to do is just plug in the URL for the Swagger. We're going to go parse it and get all the information that we need. I'm going to call this guy build conference API. And we create a resource name for it automatically, obviously. I'm going to make it accessible only from HTTPS. And then I need to assign it a unique name within API management instance, which in my case will be build conf, let's say, API, right? And then I can assign tags so that I can filter and search on them later. And I place it in a product so that it appears available to developers. And I just picked one of the products that I already defined before. So as soon as I click Create, we're going to go and create an API right there. You see it's revision 1, so it's initial sort of creation of this API. There's a bunch of operations here. We can just go in and check quickly if it's working correctly. So we'll call this operation called get topics in the test console. So when I add the product, API to a product, the key is procured and substituted here, so I can access this API. Otherwise, if you don't have the key, you can't really get to that API. So at this point, I can just make a call and get some response back. So everything's working nicely. Moreover, we have out-of-the-box developer portal experience, right, which essentially is can be styled to your liking, but looks like this out of the box. And here in the API section, you can see that the API that I imported is already there. I didn't have to do a thing, right? It's already there listed and can be discovered. And if I go and click on that, I'm going to see some documentation about all the operations here. And if I go to the same operation, get topics, right, and click try it button, I can actually call it from here as well as a developer, as an API consumer, and get the same response. And at this point, that's sort of you done, right? So at this point, essentially what we did is we imported the API and created a facade for that API, which matches exactly the API itself. And of course, from that point on, we can go and modify it. Potentially I can go and delete a bunch of operations because I don't want to expose them externally. Or I can change the name of these operations, or path and parameters that they take, or apply some other protection or throttling policies to them, which I'm going to do next. Now, to edit APIs, you can edit directly any API revision. But the safe practice is essentially to create a new revision, which will kind of create a snapshot of that API, make changes there, test them, and then deploy them. So I'm going to do that. So if you go to revisions, you're going to see that I have only one, and it's both online and it's also current, meaning that all API traffic is routed to that particular revision. So if I'm going to go and add another revision, again, I can describe here, for example, edit throttling and do create. I'm going to get basically a new revision of this API, which is online but not current, meaning that it's visible to me. I can work with it if I know its private URL, but all API traffic is still going to the previous revision. So at this point, I can actually safely make changes on this side, so to speak. And I'm going to go and set a policy on getTopics operation to restrict traffic to it. It's an easy demo, so let me just do that. So here, it's a policy editor. So this is as powerful as it gets. So you have full control here. So I'm going to just go into inbound and drop, oops, one too many. Just one more time. Rate limiting policy, right? It's kind of easy to understand. I just need to indicate what number of calls I'm going to allow per trailing 10 seconds in this case. You can indicate any throttling key you want. In this case, I'm going to use subscription ID, which is essentially defined by the key supplied. So each individual key will be throttled individually. And then the other advanced options we're going to forego for now, just delete them. So the policy is set, and at this point I can save it. And it's right there, over here, right? So now if I go to test and send a request, I shouldn't be able to send more than 2 in any 10-second period, right? So I'm getting this 429, so I'm getting throttled. So and if I keep calling, eventually I will be able to call back again as the window expires. Now, if I'm an external developer, a consumer of this API, right, I still can call this API as much as I want to, because only revision 1 is current. Revision 2 is not visible outside. It's, the traffic is not routed to it. However, if I go in and basically promote this revision to current, right, sort of swap it into production, so to speak, right, I have an option of adding a little annotation here. And we're going to be brief. At this point, you see that revision 2 is active, online, and current, which means that now people who are using the API will get the changes, right, only at that point. So if I do a couple calls and then third call, there's 429 right there, right? So that's kind of cool. I can do these things. But what if I want to evolve this API even further and introduce a breaking change, let's say, right? Well, at that point, I can actually go ahead and pick a revision, for example, and create a version from a revision. Version will be a standalone API available concurrently with the previous version, where customers or your API consumers will need to actually switch, on their own timing from the previous version to the new version. So they are really in control of how and when they're going to switch, right? And those two APIs will be available at the same time. So we have, pretty sophisticated way of managing change here. So let's do something else here. So we prepared this demo that essentially shows you how products in integration services work together. Service bus, event grid, API management, and logic apps as binding them all together. So it's a very simple example, order processing. So there's an orders API and there's an inventory API. Orders API essentially fronts the service bus queue, right? So essentially, when you call that API, we're going to post a message to a queue with that order. That message will be picked up by a logic app, which will have to go and check inventory levels, right? So it will call inventory API to check if the item is available. And then if it is, then it will do something else magical with it, right? Or act accordingly. So I'm going to show you how to build inventory API, and then I'm going to walk you through the orders API that I already pre-built just to save time. So I showed you how to build the API by import, right? But you can also build it from scratch. So you can come here and essentially say, OK, I want to build an inventory API. And I'm going to call it inventory. I am not going to bother with descriptions for now. And I'm not going to define a backend, because there is no backend, right? I haven't built the actual API implementation just yet, right? But I need to give it obviously a name, and I'm going to call it inventory as well. And then I'm going to add a tag if I want to, and then put it in the product so it's available. And I'm going to not bother with versioning. So at this point, I created essentially an API endpoint, which doesn't have any operations. So it's done right there, right? You see there's no operations available. So now I'm going to create an operation to check inventory. So for that, I'm going to call this operation check inventory. And I'm going to use the URL for, I'm going to have an items collection for my inventory. And then with this items collection, you will need to provide the name of the item and then the quantity of the item. OK? I'm going to bother with description again. I could have provided temple documentation here by describing and assigning types and things like that. I'm not going to do that. So I'm going to just go ahead and create that operation. So I've got it, right? So here's check inventory operation. If you look at it, it tells you, what the parameters are. And there's no HTTP endpoint it routes to, right? It routes to nowhere. So if we call it, it's going to actually fail, right? Because we're going to be forwarding to URL that is not there. So I need to mock it, right? Before my implementation is ready, I need to actually go and mock this particular API. So I can do it in two ways. I can do it sort of using static mocking that is available out of the box. So over here, I can actually say I want to do a static response, right? And then, we got a list of predefined responses here. You can also define your own and use that. But the trick is that every time that operation is called, we're going to return exactly the same response. So if you need something more sophisticated, I'll show you how to do it. So we're going to discard that. I'm going to go and use policies, because policies are where it's all is. So we have a few things here that could help us. First of all, we have a control flow, right? So if I want to introduce some logic, I probably need control flow. So here's what it looks like, right? It's basically it's like a switch statement, right? When first condition is met, you execute whatever it is, right, and then skip the rest, et cetera. So now I'm going to do that, plus I have another wonderful policy here, return response, right? So I need to basically say, in this case, I'm going to return this. In other cases, I'm going to return that. So I'm not going to, create this in front of you, because it's a bunch of typing. So I already have this policy pre-created. So I'm going to just copy and paste it. Here it is, and I'm going to explain what it does. It's quite simple. So here, basically, as you remember, one of the path segments is called item. So in the condition, the first condition, right, in the when condition, I essentially look at what the name is, right? And if the name is widget, I'm going to return that the item is in stock, right? And if it's anything else but widget, I'm going to return that it's not in stock, right? So that's all this mocking will do. So again, I don't have an API yet, but I already have something that I can work with and make progress. So in this case, let's go and make a call. So let's ask for a widget, 5, and we don't care about the quantity, frankly, but let's just see. And yeah, widget is in stock, right? However, if I ask for gadget, I should get out of stock response. And indeed I do, right? So again, I started with nothing, and literally in minutes, I have a functional API that my logic app developers or my front-end developers can go and work with while I'm building backend. And then through the power of revisions, right, I can safely map to the implemented backend whenever it's ready, and safely roll it into production, so to speak, so that it gets consumed by logic apps and clients without them ever noticing or knowing that something has changed. Okay? So lastly, I'm going to walk you through this order management API that fronts a service bus. And Dan gave you great reasons for why you want to sometimes do that, right? Service bus is a sophisticated technology. You might want to, first of all, hide certain capabilities and use certain settings and be in control of choosing those settings when you send messages to it. Second of all, you simplify the invocation, right? So customers who use this API use service bus, underneath, but they don't know, and you may change your mind in the end. Most importantly, they don't have to understand how a service bus works. How it has to be invoked. You don't need to provide end users with credentials to service bus, right? You switch basically the authentication mechanism, et cetera. So it's a very interesting pattern and I think very useful pattern. So if you go into design, you will see what's going on here. So first of all, you see that endpoint is service bus. Literally, there is no code in between API and service bus. We're just surfacing service bus HTTP API. So what we're doing here, first of all, we're starting by setting a content type header to the value that is understood and required by service bus queue. Next, we set another header, authorization header, which has a SAS token that I got from the service bus and stored as a name value. You see that the token itself is not embedded in the policy. It's referenced by an alias, and it lives in this named values section of the API management. Next thing I do, I define some properties for this message, specifically message ID, because I want my customers to know, to have a tracking number for that particular order. And that number will flow through the system, and it will allow correlation. What's interesting is you can see that I'm using, context.requestID expression, which is unique for each incoming request. To generate this message ID. But I, of course, could have used anything different. And then I basically say map this particular operation to the backend, which is essentially targeting service bus, orders, messages, right? And orders is the name of the queue right here. So those two guys, right, essentially construct a URL, forwarding URL for the message. So essentially, I changed, I vastly simplified invocation of the service bus. I'm in control of choosing the parameters of the service bus. I changed authentication mechanism, right? And now I have an ability to change my mind in the future because all customers know is the API, right? And with that, I'm going to yield to, one more thing.
Oh.
I'm sorry.
Right.
Yes, too fast. Just to let you guys know that we just scratched the surface with what API management can do. There's lots and lots of other capabilities that we obviously cannot go over in such a short period of time. But if you're interested, definitely there's information on the web, and you can always get in touch with us on Twitter and otherwise. And with that, John.
Cool, thank you. Yes, there's a reason we're talking about these things in the order we're talking about. And Vlad kind of pointed it out a couple of times, or mentioned it a couple of times. Everything kind of starts from some kind of source, right? So you need data, you need applications, you need some implementation, right? So you start with Service Bus, which provides the data, gives you the messages to be able to process. And those messages have got to come from somewhere, right? So each one of these things in and of itself isn't super useful because it needs something else that's backing it. So, I need an application to write to Service Bus queue and something else to kind of take those messages off the queue. When I use a grid to consume events, they've got to go somewhere. I've got to tell grid first who I am and to tell me when there's data ready and available for me to process. Same for API management, right? It's like it's a way of managing APIs you have, and the APIs you define in API management are backed by something. There's some back-end system service data source or something. In the case of the last case Vlad just showed, it's the Service Bus queue, right? That allows me to interact with these other services. And this is why we're talking about these things together, because they just make sense to work together. So the final piece that I'm going to talk about is orchestration and automation. And there's kind of aspects of workflow in this as well, because there's often people involved, right? But in the same way as the other services, what I'm really doing, and the very definition of orchestration, is taking other things, other services, data, applications, people, and making something bigger out of all of these pieces and managing it, being able to coordinate all these different system services and data sources to produce some higher value outcome of that, which is my integration implementation, the solution itself. And Logic Apps is our answer to cloud orchestration. How many of you are using Logic Apps today? A few people. How many people have heard of Logic Apps? Most people. Okay, so I'll quickly go through this then, and then I'll sort of show you kind of all of this in action. For those of you who aren't aware, Logic Apps is our Azure service for being able to rapidly create workflows and orchestration, to be able to connect things together. We have over 200 connectors to those things, whether they're data sources like SQL Server or MySQL or Cosmos or Teradata or DB2, the ability to connect down to on-premises to a lot of these data sources as well, or whether they're things like cloud services, Office 365 or Dynamics or even Salesforce or Dropbox, OneDrive. We have connectors to many, many of your applications already today. You can even create your own connectors to APIs that you already have and create a first-class connector experience out of that to make it easier for other people who don't necessarily understand your backend as well as you do when you create these connectors, to make it super easy, just like it is with all the other connectors that we ship, for your consumers of those connectors and create Logic Apps themselves without having to understand everything that's going on the back end. We have this rich, innovative designer that allows you to, through an API-first metaphor, allows you to choose from the different connectors that we have, to be able to add business logic without needing to write code, to be able to do complex orchestration, make decisions, make parallel branching, and sort of fork and join the control flows of your application, of your integration solution as you build it out. And also, of course, being able to manage and monitor this to provide a truly rich and robust enterprise-scale, mission-critical integration platform for your organization. Alongside that, we understand the value, of the DevOps story. We usually show, and I will show it right now, kind of creating Logic Apps from scratch in the Azure portal, but obviously there's more to it than that. What about when I have that Logic App running in production? How do I manage that? How do I version that? Kevin did a talk this morning, a theater session around DevOps. How do I take that Logic App and version it, deploy it, do automated things on it like alerting and monitoring? You can start with Visual Studio with Logic Apps and actually create, with the designer embedded in VS, create a Logic App right there. You'll see the ARM template, which is containing the definition of your Logic App. An ARM template can contain lots of things. It contains the definitions of all your Service Bus queues and a bunch of Logic Apps that make up your overall solution, allowing you to kind of templatize the deployment of your solution. And of course, you can then check that into source control. You can version it, you can manage it because it's all JSON. You can do diffs on it over time and understand what's changing between the different releases and do deployments from dev to test to acceptance and production to manage it. One of the things I want to make clear is the sheer kind of flexibility of the platform. These 200 connectors enable amazing things. They enable messaging and events. Whether those events are coming from IoT devices, we have Event Hub integration. Whether you're doing data wrangling, and this is really just the sort of the casual term for how do I just get stuff done when I've got data sources all over the place and I need to kind of wire them up together because I'm doing synchronization between my legacy on-prem applications to my SaaS-based cloud applications. How do I make that interaction work, and how do I make it robust, scalable, and easy to manage? B2B and EDIs, the necessary back-end operations that drive 100,000 businesses on the planet for doing things like order processing and expense management and dealing with suppliers and supply chain. MSIT did a talk on Monday about how our own MSIT kind of IT internal department and how they've transformed from an on-premises mindset of doing everything on a server-based topology to using a serverless mindset, cloud native, using Logic Apps, API management, Service Bus, and Event Grid. EAI, this sort of the legacy term, if you like, but when you talk about SaaS applications and how do I connect all of those SaaS apps together, it's really my enterprise applications. Salesforce is an enterprise application, Dynamics is an enterprise application, but they live in the cloud. I need an easier way to be able to connect all of these different applications that my users my business users, my customers internally are interacting with, and be able to get data in and out of these really easily. And the final one is really about smart integration. We have a whole bunch of connectors to Azure services, things like cognitive services, so computer vision, what else? Things like text translation and object recognition and sentiment analysis, as well as being able to run machine learning models. And this is really just scratching the surface. You can run containers through ACI and a whole bunch of other things. You can even run your DevOps processes in Logic Apps. We have GitHub integration, so you can manage your check-ins by creating Logic Apps to kind of do the sort of automation of your day, how you get things done today, which may be maybe manual. You can actually automate a lot of that using the connectors that we have with Logic Apps. So we have a very complete offering in terms of what we provide. In the center, we have Logic Apps, which kind of is this sort of overarching orchestration capability. On the left-hand side, all of these Azure services which we connect to, whether it's cognitive or API management, Service Bus, et cetera. And then all of our clouds, not just Azure services, but Office 365. Things like Dynamics. We also have this integration account for being able to manage all the artifacts in Logic Apps, which is particularly important when you're dealing with sort of message mapping using XML or doing B2B mapping using EDI protocols. And then, of course, a lot of first-party services like OneDrive as well, which are more consumer-driven services, which we provide rich access to as well. But, of course, everything's not in the cloud. You need a way of being able to do hybrid integration, connect down to on-premises. And for that, we have the on-premises data gateway, which allows you to seamlessly connect to data sources on-prem. Whether it's SQL Server or SharePoint or SAP or DB2 or even BizTalk Server, we have connectivity with that through an adapter and connector that we ship out of the box as well. And more coming all of the time. Okay, so with that, let me just switch to my machine. And I'll show you it in action, kind of join some of these things together. Okay, so what I'm going to do is attempt to build a Logic app from scratch. You can see over here that I have one that, when it all goes horribly wrong, I'll run that one instead. But for now, I'm going to start off with Service Bus. So as Dan mentioned, one of the things that is really annoying, right, especially when you've got a the service model where you're paying for everything you use, is you kind of don't want to do busy work. You don't want to do polling, just checking queues for messages. This is where Event Grid is great. So one of the features we talked about earlier in the week, Scott mentioned in the keynote, is we have Event Grid integration with Logic Apps now. So over on the side here, you have this Event Grid capability, and I can just click on this thing and immediately create a Logic app from the event itself. So I don't have to start off with the thing that's going to consume the event, which is kind of weird, right? But that's the way it's been until now, where I have to sort of decide how I'm going to process the event when I don't even know what the event is or where it's coming from. Now I can actually choose the event, and it could be storage or a bunch of other things that's growing all the time, or I can actually start with Service Bus as I'm doing here. So you can see the different options that I have. I can create a function, webhook, a storage queue, etc. But for this, of course, I'm going to use Logic Apps. It takes me straight into the Logic Apps designer. I didn't have to create the Logic app first and kind of wire it back up again. It asks me to kind of authenticate the connection to Event Grid, so I just click Continue. I will point out there's a couple of things we're working on right now around this. This is very new, so I actually just need to kind of wire this up and pick the same subscription as Vlad was just using. So I will choose Service Bus in this case and the API management subscription. And I just need to fiddle around with this a little bit. And choose the right resource name, which is that Service Bus namespace. And you can also then see the event types that I have. And there's a couple here, and I really want to sort of spend some time going through how the way the events are processed differs in some ways depending on what the events are. If you saw the session that I did on Monday around serverless, where I showed storage events, for example, you get a message, you get an event for every single one of those files that gets written to blob storage. Service Bus is a little different to that. In this case, what it actually tells me, because I'm probably going to be dealing with hundreds of thousands, maybe even millions of messages, I don't really want an event for each one of those. I want it to tell me when there is new data, right? Get the whole polling out of the equation where I'm just hammering this endpoint waiting for something interesting to happen, and have it tell me through Grid when there is data to process, and then I can go and just pick it up. If I leave this blank, I'm just going to get everything. You see it deals with both messages and dead letter messages. So I'll just take everything. I'm not expecting any dead letter messages. So I've got this event that tells me, hey, you told me to tell you when there were messages in the queue, and I'm telling you there's messages in the queue. So the next thing I have to do is go and pick those messages up. We have a lot of support for all the features in Service Bus and Logic Apps. What I'm going to do here, scrolling down this massive list, is get messages from a queue and peak lock. So a lot of people struggle sometimes with moving applications and re-architecting for the cloud because they need sort of this notion of kind of transactionality, right? What happens if I picked up these messages from the queue and then something bad happened? Do I lose data? The answer is no. I can use peak lock, which allows me to highly parallelize access to resources like queues. It allows me to just then pull the messages as fast as I can across different instances of Logic Apps without duplicating data and without losing any data. So I can do a peak lock, and what happens is if something bad did happen, after the sort of timeout period of that lock, I'm basically saying, give me the messages and lock them while I process them. And then if something bad happens, the messages will be put back on the queue, they'll be unlocked, and another instance will just pick them up and process them. So I just give it the name of the queue. You can see it's defaulted to pull 20 messages at a time, because remember, the event is just telling me there are messages. It doesn't tell me how many. The next thing I want to do is actually do some work on this message, because I don't know what's in it, right? And it's actually got JSON content in it, so I'm going to use one of our data operations called compose. Oops, sorry, wrong one. I actually want parse JSON, excuse me. I'm going to use parse JSON, which allows me to provide a schema. Compose lets me create messages, but in this case, I already have one. I'm going to use parse JSON. I provide the content. You see the experience here is that I can just choose from the list of data items that Logic Apps already understands by virtue of all these API definitions that are underneath all of this. So it knows when you connect to a SQL server what all the tables are in that SQL server, and then all the columns in the tables when I run the queries and get the data back. So I can then just pick the data items and map them in and out of each one of these actions. So I can just pick the content and see what happens immediately when I do this. It's wrapped it in a for each automatically, because it knows from the output of the preceding action that it's an array. So it could be one or more messages. So that's great. It's actually base 64 encoded with this, so I'm just going to cheat a little bit and use an expression which decodes this message. And then cheat a bit more and put in this JSON schema. I'll show another example of this in a minute. So this is what I'm expecting the message to look like. It's got a customer name, it's got an item, and it's got a quantity in it. And this is Vlad's API that he showed earlier. What this does is it allows me to then, with full fidelity, pick each one of those data items out of the message that I've just picked up from the Service Bus queue. So I'm processing an order here. I'm wired up to the orders queue. So I want to check inventory. I want to use that inventory API that Vlad created. So I can just pick my API management instance and look down, and I should find inventory management. Go into that, and then I can see, check if an item is in stock, which is awesome. And I can then wire this data up so I can take the incoming message and map in the item that I'm interested in. and make sure that it's in stock. You can see it's defaulted to widget and 5 because Vlad defined that in his original mock API. I'm just going to leave those as it is. The only other thing I need to grab, and just look away for a second while I do this, is I need to grab the API key for this thing, which Vlad will probably change immediately afterwards. So let's just do that. Nobody saw that, right? So I've now got the message, got the event, got the message, looping over each one of the messages that I received, mapping it into my JSON schema format, and then doing an inventory lookup. The next thing I need to do is, because again, I don't know what I'm going to get back, so I can do a parse JSON again, and just pick the same data operation, pick the content. You can see kind of what's happening here is that I can see the body of the API management response after calling that API. I can use a great tool called jasonschema.net, which was actually open on my desktop and now isn't. So what I will do is if I actually sort of run this API, this inventory management, I will just grab the results, which is, which is this, right at the bottom. This is what I get back, this item widget in stock equals true. So I can just generate a JSON schema for this. So this is a great web-based tool. I'm just going to switch off some of the options. It allows me to, right in front of all of you, create a new JSON schema. Just hit the button, change it to plain because I don't want the line numbers, and just copy that to the clipboard, pop back, and just paste that straight in. And now I can make a decision because I have full access to all of the data flowing through my system. So I can just pick, is it in stock or not? Make the decision, say yes if it's in stock. I want to just compare that with true. It's a Boolean. And then I'm going to send myself an email, or more likely, send somebody in my organization an email that an order has been received. So I can pick the Office 365 connector. We have Gmail and Outlook.com and a whole bunch of others to do this. But in this case, I'll just use my email account I set up earlier, and I can create an email message. So I'm just going to send this to contosoproducts@outlook.com. Let me just zoom in so I can read it as well. That's good. I can give it a subject and say, new order from, and I can choose, again, from the rich set of data that I got here, the customer, and I can say, please process order for, scroll down, grab a couple of more data items, and say order for quantity of item. Now, I still haven't created a logic app here, right? I'm just in the designer that I linked to from EventGrid, from that service bus queue. So I can now do save as, and I can give this thing a name. Let's give it something more inventive than new logic app. Let's call it something really stunning like build 2018 demo. I will just put this on my desktop and click create. And it's now actually going to create the logic app definition that can now run when there are new events appearing. So it's going to light up on the desktop here. And I'll use while it's doing that, I will use oops, there's one thing I forgot to do. I didn't complete the message. I know this is going to cause me this problem. I'll do that in a second if I get time, because we're sort of starting to run out. So I can just go back to this API and use the order management one this time, because that's going to be able to put messages in this queue. Just to sort of show there's nothing up my sleeves. I've got my email, I think, open here, nothing in my inbox. Who wishes they had an inbox like this? And I have Service Bus Explorer also showing me there is nothing in this queue. So I can just go ahead and call that API, submit new order. It's got a default message already for those widgets. Yeah, I can get the scroll bar right. So I just send this in. This is going to put a message in the queue. Not terribly exciting, right? But it's going to put a message in the queue. And then EventGrid is going to tell my logic app that there is new data to process. Hopefully this will happen in just a couple of seconds. Let's just give it a moment. And it's finished already, so I can just open this up, and you can see what actually happened, that it took the EventGrid event message, then went to Service Bus and grabbed all of the messages. It looped around, so you can see my for each loop. I have an iterator here, so I can say, I can actually spin over each one of the iterations of this loop to look at each individual message. Because when I look at parse JSON, I can look at the output of this thing and see, yes, that was my customer Contoso widget 5. And kind of look through the whole run history of this. I call the API. Let's have a look at what the results of that were. It's in stock. It's true. Therefore, hopefully, it went down my branch here on the true side and sent me an email showing me that the item was in stock. So if I pop over here and look at my email, you can see there it is. I've got an email from that data, which was put in a Service Bus queue via an API that then used Event Grid to trigger my logic app and sent me an email with the contents of it. Super simple, right? Previously to this, you'd had to kind of create all these pieces individually and kind of wire them all up, and now we're driving an experience where you can just start with what you want to work with. Start with the event, start with the data, start with the files, start with the Service Bus queues, topics, subscriptions, whatever, and create integrations from that super easily. Just wire it all up. We just kind of get all the noise out the way so you don't have to wire it up to the right subscription, the right Service Bus topic, or the right storage account. We do it all for you, and you just hit save once you've implemented your logic in your logic app itself. Okay, oops, I don't need to go back to those slides. I need to go back to these slides. Okay, so a few other things. There's a number of ways in which we can connect, using our sort of hybrid integration capabilities with logic apps. One of the ones I mentioned is the data gateway. This uses Service Bus Relay to make connectivity down to your systems on premises, whether it's data sources like SQL or DB2, whether it's line of business systems like SAP. But you can also do things like API management. This gives you the advantage that API management can run in a VNet, for example, so you can have API management called by logic apps by consuming those APIs, and API management actually accessing resources directly. And then the final one, which is kind of an interesting one because it's so ubiquitous, that it has so much reach, is using Service Bus to do this. One of the great things about Service Bus is it doesn't just have kind of programming APIs for your favorite programming languages, as Dan showed with C#, or I can just program against this stuff. That kind of gets tedious, right? I'm just writing boilerplate code all the time. You can also use logic apps and use the connectors that we have to kind of get and pull and push messages in and out of queues and topics. But it also has a web-based API as well, which means I can call it from pretty much anything. If I had an IBM mainframe that I wanted to pull messages off one of these Service Bus queues, provided it has network connectivity, I can do that too, right? So if I had a Unix-based system for which I didn't have programming language support for that platform, I can just use the web-based APIs to be able to do that. So great reach to be able to work with Service Bus wherever your applications and data resides. Okay, one of the other things I really wanted to mention, and I've got to thank Gartner for letting us share this with you here today, is that this was published a couple of weeks ago, as we're now being recognized as iPaaS leaders by Gartner for 2018. So we're up here in the sort of top right-hand corner as one of the best, if you like, in terms of visionary and execution around integration, enterprise integration platform as a service. We have a link as well. You can go to aka.ms eipaasmq and download the report yourself and read about logic apps and how Gartner thought we shaped up in terms of the offering that we provided and really the progress we made over the last 12 months. A lot of that's thanks to those of you who put your hands up earlier on, who are already using logic apps and providing great feedback to drive us to implement all features to keep you happy and help you implement your solutions as easy as possible. Okay, but we've really just scratched the surface. I'm not going to go through this full list. The one I will point out at the top, because it's really soon, is integration services environments. So this gives you the ability with logic apps to create your own isolated stamp, your own set of compute with its own dedicated storage, with VNet connectivity, to be able to create logic apps almost in your own private region. So when you create a logic app and do that save as, you'll pick your own private integration service environment to create that logic app in. And then that logic app doesn't need the data gateway. You can lock things down and be able to access things like SQL and FTP and other services directly in your on-premises environment inside your VNet. So for those of you who have kind of security or regulatory requirements or just love VNets, you'll be able to have logic apps participate in your VNets with API management and all the other things you can put in a VNet, as well as, of course, your own resources in your own data center on premises. But there's a whole lot of more stuff here. You know, custom connectors, APIs aren't necessarily just about JSON and REST. They're also SOAP-based for those of you who have kind of web services using XML, and we have full support for that as well. Most of these things I've already mentioned, so I won't go through them. But you know, if you haven't looked at Logic Apps, I urge you to take a look. We move very quickly and ship new features like almost every week. So if you didn't look at Logic App for 6 months or a year, I'd urge you to look at it again because things have really moved on. You know, we shipped you know, a whole bunch of connectors, over 100 connectors just in the last 12 months. Okay. So let's sort of wrap this up. You know, what did we cover? I talked about integration services in Azure, the importance of and the value really of using these services together. We have designed them and thoughtfully tried to make these things work well together. That's why we have such rich support for Service Bus and Grid in Logic Apps. It's why we have integrated capabilities to be able to import a Logic App definition into API management to actually create an API head on top of an existing Logic App. And of course, as I showed, to be able to consume an API directly from Logic Apps as well. The importance of using messaging and events, you know, getting away from having to poll, being told through, you know, you saying in advance of time that I'm interested in these particular things. Hey, you just tell me when they're there, and I'll go and get them. Is super powerful to be able to sort of wire loosely coupled, scalable cloud-based architectures together in Azure. And then how to create and consume and manage APIs with API management, just how easy it is to get started. You may not even have the implementation of that backend API. You can mock it up and test it before you wire up the actual backend because another team may be working on that and implementing that. And then finally, being able to orchestrate in the cloud, you know, at cloud scale, how to run, you know, we run billions of Logic Apps every month. 24/7, you know, how to get the reliability of connecting all of these things together so that you can sleep safely at night knowing that we're taking care of all of this for you because it's serverless, because you don't have to manage all the underlying infrastructure yourselves anymore. You can just focus on the solution itself. Okay, one of the final call-outs I'll make is we have a hands-on workshop covering all of this afternoon at 4:30. A few guys from the team, from Christian from the Service Bus team, Derek from my team, and Meow from the API management team. I think most of them are sitting in this room. Go along and try that out before you start to party at the celebration tonight. You know, make it the last thing that you do to actually get some hands-on experience in building out one of these solutions using all these different services. And some other sessions which I'm calling out, which are early in this week, which have all been recorded, or that you can also take a look at in your own time. And with that, I will say thank you and have fun.